All right, I wanted to quickly work a couple of problems that I've posted. I posted this sheet, but I wanted to kind of go over it in a couple of instances for you. Say a few things and see if that helps. So we're calculating first set of problems we're doing decibels, and the definition of a decibel, remember, is a ratio of the intensity to the reference intensity, log base 10 times 10. So that's your reference intensity. This is just definition. You just plug the numbers in when it gives you I naught, take the log of that times 10. There's your answer. Okay, that's straightforward. This one's about how the sound gets less loud as you get away, as the average output by the source divided by the area of a sphere, or pi squared. And so here it gives us a distance and an I, and he wants to know how much quieter, or what's the intensity further away. And so what I'm going to do is I'm going to put my numbers in. I'm going to take the ratio of I2, because P average is the same, 4 pi or 2 squared over I1. P average, because I know everything except for I2. Cancel, invert multiply, cancel. And so the ratio of intensities goes like the ratio of how far you are away. So I solve that for I2. Just plug I1 times this ratio of the square of those intensities and you get your answer. So take the ratio. You could solve for P average and plug it in. That's not the only way to do that one, but that's how I'd like to do it. Here's one where you've got two sounds, and the trick here is that the intensities actually are the ones that add. So you take your 2 decibel levels, use your definition, but what we're going to do is we're going to solve the decibels for the intensity. Give me the decibels, find intensity. So that's the opposite problem. So do a little algebra here. Divide by 10, make both sides power 10 because the logarithm and exponential are inverses. 10 log x is x. So that gets rid of, and of course I move my I over I naught to the left to be more traditional. So that gets rid of it here, but not over here. Multiply. So if you have the beta and want to get the I, then use this formula. So I do that for I1, which is the music. I do that for the baby, which is I2. And then I add the intensities, and then you don't add the decibels, but you add the intensities, because remember, logarithms are exponents, so you don't add the exponents. And then you go back after you've got the new intensity, use your formula and get your decibels. Okay? And then we wanted to do the Doppler. I'm going to use a number of 331 meters per second for sound. That gave me the right answers. You could probably, so within 10%, you can probably go up to like 340. But the default number, remember, was 331 at 0 degrees. So anyway, what we have is we've got a police car, which is our source, moving at us. He's coming at us, and we're over here. We both have a velocity. And the trick is that you decide, you remember my formula, upper signs away, lower signs away. Well, you're going to decide who's away really relative to the air. So in this case, our source is our car. I'm sorry, our observer, O, is our car. Our source is the policeman, VS. So that's the speeds they gave me. And that's the frequency of the siren. Well, there's a typo. Let's make that an O. The source is, the car's moving toward the observer, and the observer's moving toward, I think that one's pretty obvious. And so we take the upper sign, we evaluate each one, and so I take the upper sign for the car, the upper sign for the source gives me plus and minus, gives me that. Now once he passes, now I've drawn them, technically that formula would be headed toward each other because that wouldn't make sense. And the reason we hear a sliding scale when we do that is because of the angle. The velocity is actually changing, right? It's going to be related to the sign, the opposite of the angle. So we actually hear that effect. This would be what we hear when he's way down there when there's not much angle. All right, now here, after the car passes us, now the car is moving away from the policeman and the policeman is moving away from us. So we do the lower signs of both. A lot of typos here because I'm not using I don't have the spell checker. So you are CE. And so we're still using the same speed of sound and the same V0 and VS. All right, then part C, he changes it a little bit, and he says, let's suppose the cop were coming at us. So we're we're driving along, and we hear the siren from behind us, look in the rearview mirror, get all nervous. And so, but now, the car's moving, and the cop's moving. The car's moving away. Think of, to decide, assume the other one's sitting still, like the air. Assume the air's sitting still. So the car's moving away from the policeman, but the policeman's moving toward. So lower sign on top, upper sign on bottom, which makes them both negative if you go back and look. And so calculate it that way. And then once he passes me, then he's moving away, not away, and I'm moving toward him. So in that case, it's upper and lower. So both positive, and we get that. And that's kind of the hardest thing sometimes is deciding who's up and away. The videos and the problems on Webassign may show it a little bit different. Some people use a plus and minus sign with a little bit different formula. This is just the way I like to do it. Hope that helps.